Okay, let's see how this works. I'm at home, you're at home, but I guess you'll be ready to study. The video is basically going to be for year 11 standard level. It can also be used by year 11 higher level and year 12 if you want to revise the basics of kinematics. In this case, we are going to solve the problem that I handed out last class about the problem coming from IDVA. I'm going to show it in a minute. The advantage of this video is that you can go find the page, try the problem, then come back and let's say pause the video and then start over. The problem reads, and you should remember and you should have the page in front of you right now, so go get it and please stop talking. It says, un globo aerostático asciende verticalmente con una rapidez de 13 metros por segundo. Se observa que al pasar por una altura de 300 metros respecto del suelo, se desprende de una pequeña bolsa de lastre y en ese momento se dispara un proyectil verticalmente hacia el globo con una rapidez inicial de 73 metros por segundo. We need to determine the height from the ground where the projectile hits the balloon. Balloon is going at 30 meters per second from a height of 300 meters. Constant velocity, the projectile is going with an initial velocity but decelerating because of gravity. So let's try to solve it. Let's see. This is the basic idea. Let me focus. I don't have good lights. So, balloon going at a initial velocity, which is a final velocity, which is a constant velocity of 30 meters per second. Now, important thing to remember, if the velocity is constant, it means that the forces are balanced. Sum of forces equals mass times acceleration, as you might remember, and therefore, if the forces are to be balanced, the weight has to be cancelled out by a force pointing upwards. What force is that? That is what we call the upthrust, connected with the difference in density by a balloon which has a very hot gas and therefore is in total, overall, less dense than the air, and therefore is going up or is being pushed up by a force, but that is being balanced by the weight, therefore constant velocity. Now at the same time we drop a bullet at a velocity of 73, too small, the writing is too small, 73 meters per second, gravity is minus 10 because it's pointing downwards. So what we know is that the balloon will cover a distance s in the y direction, which is 13t. Why 13t? Well, it's very easy. Velocity is distance over time, average velocity. So in this case the velocity will be constant, so the distance will be vt. V is 13, t is the time taken. It will cover 30 meters in 1 second, 26 in 2 seconds, etc., going always upwards at a constant velocity. Now the bullet needs to cover a distance of sy plus 300 because it needs to meet the balloon. It is starting with 300 meters behind, so it will go at a velocity of, it will cover a distance of 73t plus 1/2 at squared. A is minus 10, so it will be 73t minus 5t squared, but that distance has to be the same of the balloon plus 300. So when we equate these equations, we get that 13t, which is sy, plus the 300 extra, and that's the distance that the bullet needs to cover to find the balloon, equals 73t minus 5t squared. If you work out the quadratic equation, you will have a problem. Problem is, yes, you'll get a negative in the root. Now, unfortunately, I didn't double check the problem. I got it from IDVA. So, problem is wrong. And somehow it's obvious. I mean, it cannot be negative, the thing in the root, of course. And the idea is that with an initial velocity of 73 meters per second, if that is the initial velocity, we know it takes 7.3 seconds to stop, to go to a final velocity of 0. Remember that the bullet is accelerating. Initial velocity 73 meters per second, is losing 10 meters per second every second, in 7.3 seconds it will have stopped. In that case, the average velocity from 73 to 0 will be 36.5, 73 plus 0 divided by 2. And at that average velocity of 36.5 during 7.3 seconds, it will only cover a distance of 200 and something. You can calculate basically 36.5 times 7.3, it is less than 300. So it cannot catch up, it cannot reach the balloon. So, task for you. You will solve the problem, but you will try, assuming that the balloon is at an initial height of 100 meters. So, the problem is, balloon is at 100 meters going upwards at a speed of 13 meters per second. We shoot the bullet at an initial velocity of 73 meters per second. We want to know how long it takes for the bullet to reach the balloon, and what height. If you do it correctly, the answers for the time taken will be either 2 or 10 seconds. 2 answers? Yes, quadratic equation, we get 2 answers. 3 equals 2 seconds means that the height will be 126 meters. Now the question is, what's going on with the other? What's the other one representing? Well, if you want to plot a distance time graph, if you then draw the ST graph, displacement time, you'll see that, well, this equation, the straight line, is basically the displacement time for the balloon with a gradient of 13 because it's going at a constant velocity. So the gradient of a displacement time, which is the velocity, has to be constant. But the other is a parabola, and the parabola is starting at minus 100, and it will reach it will intersect the straight line at 2 points. Of course, if we actually do it, the bullet will first hit the balloon. But if it didn't, let's say if it misses it, it will go beyond it, it will slow down, it will start falling, and when it falls, it will reach it again. And that's what the second point is representing. So try to solve the problem. If you have any question, you can email me. And next task, which means next video, will be explaining a bit more about this and addressing this problem, the one that you should also have, that in case you don't, I will read, and I will be more comfortable to read it. And it says, with this simple diagram, it says, se deja caer un objeto desde el punto A, desliza sin roce, meaning neglecting friction, por la superficie curva, y en el punto B, the lowest point, comienza a deslizar sobre el plano horizontal, now with friction, with a friction coefficient of mu. La velocidad del objeto en el punto C es la mitad de la velocidad en el punto B. Calcule la altura A respecto al plano horizontal para tirarlo y que efectivamente pase eso, sabiendo que la distancia BC es de 3 metros y el coeficiente de fricción es 0.25. Next video will be about this problem. Try it, you should have it in your folders. And see you later, alligator.